The Capacitor Simulation is an interactive educational tool designed to help students explore and understand the principles of capacitors and their behavior in electrical circuits. By providing a hands-on approach to investigating the relationship between capacitance, plate separation, and plate area, the simulation offers a comprehensive learning experience that covers fundamental concepts in physics and electrical engineering. The simulation allows students to connect a capacitor to a light bulb and experiment with a discharging RC circuit, providing insights into the dynamics of capacitors in practical applications. Capacitance is the ability of a capacitor to store electrical charge. The capacitor simulation begins by introducing the concept of capacitance, explaining how a capacitor stores and releases electrical energy. Capacitance is determined by the physical properties of the capacitor, including the plate area, the distance between the plates, and the dielectric material between the plates. The simulation provides an interactive platform where students can actively engage with the concept of capacitance. By adjusting various parameters, such as plate separation and plate area, students can observe how these factors affect the capacitance of the capacitor. This hands-on approach helps students gain a deeper understanding of the principles governing capacitance. The capacitor simulation allows students to explore the relationship between capacitance and plate separation. By adjusting the distance between the plates, students can observe how the capacitance changes. As the distance between the plates increases, the capacitance decreases, and vice versa. Students can also investigate the relationship between capacitance and plate area. By adjusting the area of the plates, students can observe how the capacitance changes. As the plate area increases, the capacitance increases, and vice versa. This relationship helps students understand the importance of plate area in determining the capacitance of a capacitor. The simulation allows students to connect a capacitor to a light bulb and experiment with a discharging RC circuit. An RC circuit consists of a resistor and a capacitor connected in series. When the capacitor is charged and then disconnected from the power source, it begins to discharge through the resistor, causing the light bulb to glow. Students can observe the discharge process of the capacitor in real time. As the capacitor discharges, the voltage across it decreases exponentially, and the current through the resistor also decreases. The light bulb's brightness diminishes over time, providing a visual representation of the discharge process. This interactive feature helps students understand the dynamics of a discharging RC circuit and the behavior of capacitors in electrical circuits. The time constant is a crucial parameter in RC circuits, defined as the product of the resistance and the capacitance. The time constant determines the rate at which the capacitor discharges. By adjusting the values of the resistor and the capacitor, students can observe how the time constant affects the discharge process. The simulation allows students to measure the time constant precisely. By observing the discharge process and the decay of the voltage and current, students can determine the time constant and understand its significance in the behavior of RC circuits. This feature helps students gain insights into the dynamics of capacitors and their applications in various electrical systems. The simulation provides an interactive platform where students can actively engage with the concepts of capacitance and RC circuits. By adjusting various parameters and observing the results, students can gain a deeper understanding of the principles governing capacitors and their behavior in electrical circuits. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the changes in capacitance, the discharge process, and the decay of voltage and current in real time, helping them to grasp complex ideas more easily. The simulation offers immediate feedback, allowing students to see the results of their adjustments instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. In conclusion, the capacitor simulation is a valuable tool for teaching and learning about the principles of capacitors and their behavior in electrical circuits. By providing an interactive, visual, and comprehensive platform, it helps students understand the relationship between capacitance, plate separation, and plate area, as well as the dynamics of discharging RC circuits. The simulation allows students to connect a capacitor to a light bulb and experiment with the discharge process, providing insights into the practical applications of capacitors. Whether used in a classroom setting or for individual study, this simulation can significantly enhance the learning experience and build a strong foundation in physics and electrical engineering. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating world of capacitors and their applications in various scientific and engineering fields.